Think you've got gravity figured out? Stand on a scale. Watch the number appear. Earth's pull dragging you downward. Elementary stuff. Release an object from your hand and observe it drop. The moon circles our planet. Celestial bodies orbit the sun. Masses attract one another. Newton solved this puzzle hundreds of years ago. This so-called gravitational force appears straightforward to grasp. Obvious, even. Except it's completely incorrect. Not slightly off, fundamentally mistaken about the actual phenomenon occurring. Gravity isn't a force whatsoever. Once you genuinely comprehend what gravity truly represents, the entire cosmos begins appearing radically different. Let me demonstrate. Get on your feet this instant. Notice the sensation of your weight. What exactly are you experiencing? You claim it's gravity, Earth yanking you downward. But consider the actual physical sensation. The floor presses upward against the soles of your feet. That's the sensation you detect. The floor exerting upward pressure. This enigmatic downward pull everyone discusses? You never actually feel it, not even once. You exclusively feel upward pressure, constantly pushing upward, never tugging down. So where's this alleged pull located? Here's something even more peculiar. The moon is plummeting toward Earth at this very moment. It's been falling for billions of years, yet it never approaches any closer. It just revolves. Perpetually falling, never making contact. What sort of pull operates that way? A pull that continues pulling eternally but never actually draws anything inward. According to Newton, that pull operates instantaneously. Shift Earth's position and the moon senses it immediately across 240,000 miles of vacuum. Instantaneous transmission? How does that work? What medium carries this information? What mechanism enables it? Newton himself couldn't provide an explanation. He labeled it action at a distance and confessed he didn't comprehend its operation. But his mathematics was elegant. His predictions were flawless, so people ceased asking uncomfortable questions. That was their mistake. Travel back several centuries. Nobody understood planetary motion. Copernicus declared they orbit the sun. Acceptable. But how exactly? What trajectories do they trace? Tycho Brahe constructed an observatory and invested decades recording planetary positions. Night after night, year after year. He measured angles using brass instruments with precision down to fractions of degrees. Why demand such accuracy? Because comprehending nature doesn't happen through speculation. You must observe, measure with care. Document precisely what appears before you. That's where authentic science originates. His data eventually reached Johannes Kepler. Kepler sought to determine the geometry of planetary orbits. He attempted circles first. The predictions came close, but Mars deviated by 8 arc minutes, 8/60ths of a degree. Most investigators would dismiss that as measurement uncertainty. But Kepler recognized Tycho's capabilities. That observer didn't commit 8 arc-minute errors. So Kepler discarded his entire theory and began fresh. After years of intensive work, he discovered the answer. Ellipses. Planets trace elliptical paths with the sun positioned at one focus. Perfect correspondence with the observations. Magnificent. But it generated a more significant question. Why ellipses specifically? Meanwhile, Galileo was conducting elementary experiments, rolling spheres down inclined planes. Sounds insignificant, but observe what occurs. Roll a sphere down a slope and it accelerates. Allow it to continue onto a horizontal surface and it maintains motion. It doesn't halt immediately. Now imagine eliminating all friction completely. What would result? The sphere would roll indefinitely. Identical speed, identical direction, perpetually. This troubled people. Surely motion demands continuous force application. Surely objects naturally arrive at rest. No, that's inverted thinking. Motion represents the natural state. An object traveling in a straight line requires no explanation. That's the default condition. What demands explanation is alteration. Deceleration happens through friction. Acceleration requires applied force. Direction changes demand sideways forces. This concept is inertia, the foundational law of motion. And it generates a paradox. Planets should travel in straight lines. That's their natural state. Yet they don't. Their paths curve continuously. Their trajectories perpetually bend toward the sun. Something must be deflecting them every instant. What force accomplishes this? Isaac Newton perceived it with clarity. Planets desire straight-line motion. That's inertia. Yet they curve. Something alters their motion constantly. He termed it gravity. Universal attraction operating between any two masses. The force magnitude depends on mass and separation distance. Greater mass produces stronger force. Larger distance produces weaker force. Precisely, force diminishes with the square of separation distance. With this singular principle, everything aligned. Why ellipses? Because planets are falling sunward while simultaneously traveling tangentially. The combination produces elliptical trajectories. Kepler's laws emerge organically from Newton's force law combined with inertia. Why does the moon orbit Earth? Identical principle. It's falling earthward while moving sideways sufficiently fast to perpetually miss. It falls around Earth rather than into it. Why does an apple descend? Earth attracts it. Same force, same law, merely different magnitude. Newton performed an elegant calculation. He determined how much the moon falls each second, how much its trajectory deviates from linearity. Then he calculated how much objects fall at Earth's surface. The values matched perfectly after accounting for distance. Revolutionary insight. The force pulling an apple is identical to the force maintaining the moon's orbit. Celestial and terrestrial mechanics, unified physics. With Newton's law, phenomena made sense. Ocean tides occur because the moon exerts force on Earth's water. Earth is spherical but equatorially bulged because of rotation. Comets return on predictable timetables because they follow elliptical orbits. Peculiar observations found explanations. Jupiter's moons sometimes appeared ahead of schedule, sometimes behind. This revealed that light requires time to propagate. When Earth is more distant from Jupiter, light takes longer reaching us. This enabled measuring light speed for the first time. Planets wobble slightly because they exert forces on each other, not exclusively on the Sun. From the wobbles in Uranus's orbit, astronomers predicted another planet, Neptune, and located it precisely where predicted. For 2 centuries, Newton's gravitational law stood as among science's greatest achievements. It explained everything anyone could measure. But one detail remained inexplicable. Release a hammer and a feather in vacuum. They strike the ground simultaneously, perfectly together. The hammer possesses greater mass, so according to Newton, gravity pulls it harder, substantially harder. But the hammer also possesses greater inertia. It resists acceleration more intensely, substantially more. These two effects cancel perfectly. Not approximately perfectly. Every object falls at identical rates regardless of mass. Why? Newton's theory requires 2 distinct properties of mass. Gravitational mass determines attractive force strength between objects. Inertial mass determines acceleration resistance. And these 2 properties remain perfectly proportional for every substance ever tested, to incredible precision. But why should mass's attracting property and its acceleration resisting property be perfectly equal? Newton had no answer. Just the remarkable coincidence that made his mathematics work beautifully. Or was it truly coincidence? Einstein asked a different question. What if it's not coincidence? What if that perfect equality reveals something fundamental about gravity's actual nature? Consider this thought experiment. You're inside a sealed room without windows. You sense your normal weight pressing you floorward. Are you on Earth, or are you inside a rocket in deep space accelerating upward at 9.8 meters per second squared? Can you distinguish between them? Release something and it falls to the floor in both scenarios. Throw a ball horizontally curved trajectory in both scenarios. Stand on a scale identical reading in both scenarios. No experiment can differentiate them. This is the equivalence principle. If you genuinely cannot distinguish gravity from acceleration, perhaps they're identical phenomena. Perhaps what we call sitting motionless in a gravitational field actually constitutes a form of acceleration. Here's Einstein's revolution. Objects in freefall experience no force acting upon them. The falling apple, the orbiting moon, satellites circling Earth, astronauts floating in space capsules, none experience any force. They're moving naturally, following their natural trajectories. No forces, no pulls, nothing acting upon them. But the apple is clearly falling. Correct, but what if the apple isn't accelerating whatsoever? What if it's following the straightest possible trajectory and it's space itself that's curved? This is Einstein's profound insight. Gravity is not a force between objects. Gravity is space-time curvature. Massive objects don't pull on other objects. They warp surrounding space. They bend it, curve it, distort the geometry. The apple isn't being pulled groundward. It's following the straightest possible path through curved space-time. But space-time near Earth is curved, so straight aims toward Earth's center. You standing on the ground aren't being pulled downward. You're attempting to follow your natural path through curved space-time, a path toward Earth's center. But the ground obstructs you. The ground pushes you upward, preventing you from following that natural trajectory. That's what you sense as weight, not gravity pulling down. The ground pushing up, deflecting you from your natural trajectory through curved space-time. Einstein made a concrete prediction. If gravity is genuinely curved space-time, then light should be affected too. Light possesses no mass. In Newton's theory, gravity shouldn't affect light whatsoever. But if gravity is space curvature itself, then light following the straightest path through curved space should bend. During a solar eclipse, astronomers measured star positions near the sun's edge. The stars appeared displaced from their true positions. The starlight had been passing near the sun exactly as Einstein predicted. This is gravitational lensing. We observe it constantly. Massive objects bend light from more distant objects behind them, creating distorted images. Direct evidence that space itself curves in mass's presence. Astronauts in orbit appear weightless, floating around. Zero gravity up there, correct? Wrong. The gravitational field at satellite altitude, a couple hundred miles up, is nearly as strong as Earth's surface. Approximately 90% as strong. So why do astronauts float? Because they're falling. The capsule is falling. Everything is falling toward Earth constantly. But they're also moving sideways extremely fast, about 17,000 miles per hour. As they fall, Earth's curved surface drops away beneath them. They perpetually miss. They fall around Earth rather than into it. Everything falls together at precisely the same rate, so there's no sensation of falling. No weight, no sense of up or down. It feels exactly like floating in empty space distant from any mass. This is equivalence in action. Free fall in a gravitational field feels identical to floating freely in empty space because they are the same thing. In free fall, no force acts upon you. You're following the natural geometry of curved space-time. Consider Earth's surface. It's curved, but standing on it, it appears flat to you. And here's something remarkable. Why is Earth round initially? Because of gravity, but not how you imagine. It's not that some force is pulling everything toward the center, sculpting Earth into a sphere. It's that space-time around Earth's mass is curved equally in all directions. Every piece of rock, every drop of water attempts to follow the straightest path through that curved geometry. And when everything follows those curves from all directions equally, you obtain a sphere. The only shape where every surface point is equidistant from the center. Earth is round because that's what occurs when matter follows curved space-time. The shape emerges naturally from the geometry. An ant walking what it perceives as a straight line on that curved surface actually follows a curve. But from the ant's perspective, it's proceeding perfectly straight. That's what's occurring with everything near Earth, except it's not merely space that's curved. It's space and time together, space-time. Massive objects create curves in space-time. Depressions, wells, distortions. The sun creates a deep well. Earth creates a smaller one. Even you create a tiny well, too minute to measure easily, but it exists. Objects moving near these wells naturally follow the curves, not because anything pulls them, because they're following the straightest possible paths through curved geometry. The moon orbits Earth because it's following the natural geometry of curved space around Earth. That geometry makes the straightest path into a circle. An apple falls because it's following curved spacetime near Earth's surface. In that curved geometry, straight ahead through time aims toward Earth's center. When you throw a ball, it follows a parabola, not because gravity pulls it down, because it's moving through curved spacetime, and the straight line in that curved space appears as a curve to you. You're standing right now. You sense weight. In Newton's picture, gravity pulls you down and the floor pushes you up. Two forces balanced. In Einstein's picture, only one force acts upon you, the floor pushing up. But if there's only one force, you should be accelerating. And you are. You're accelerating upward constantly. The natural path through spacetime aims toward Earth's center. That's the freefall trajectory. But the floor obstructs you. It pushes you upward, deflecting you from that natural path. You're like someone standing in an accelerating rocket. The floor pushes. You sense weight not from any downward pulling force, from being accelerated away from your natural path. The apple hanging in a tree is also being pushed upward by the branch. When the branch breaks, the pushing ceases. The apple is suddenly free to follow its natural path through curved spacetime. It falls, but the apple isn't accelerating. The apple is finally free to move naturally. You standing on the ground are being constantly accelerated upward by the floor pressing against your feet. Falling is the natural state. Standing still requires force. That's Einstein's revolution. Once you comprehend gravity as geometry, extreme phenomena make sense. A star is essentially a massive gas sphere. Its mass creates a deep well in spacetime. The natural paths in that curved space aim inward. What prevents collapse? Pressure from nuclear reactions in the core pushing outward. Balance. When nuclear fuel exhausts, pressure drops. Balance breaks. The star collapses. If the star is sufficiently massive, collapse continues until matter is compressed to incredible density. Atomic nuclei merge. Electrons are crushed. What emerges is a neutron star. Nuclear matter compressed to city dimensions. A teaspoon of this material would weigh 1 billion tons. For even more massive stars, not even neutron pressure can halt collapse. Spacetime curves so sharply that all possible paths lead inward. Even light cannot escape. This is a black hole. Near a black hole, spacetime is so severely warped that light itself, following the straightest possible paths through this geometry, spirals inward and never emerges. We can't observe black holes directly, but we observe their effects. Matter falling toward a black hole accelerates, heats up, radiates enormous energy before disappearing. All from one idea: mass curved spacetime. Objects follow the curves. From this singular principle, everything follows. Planetary orbits, tides, the precession of Mercury's perihelion, a tiny effect Newton's theory couldn't explain, but Einstein's predicts perfectly. Gravitational lensing, black holes, gravitational waves rippling through space when massive objects collide. The same principle explaining how the moon orbits also explains the largest structures we observe: galaxies, clusters of galaxies. Universal elegant. The pattern in the small piece reveals the design of the whole fabric. Newton's equations work beautifully for practical purposes. We use them to launch satellites, calculate orbits, predict eclipses. They're simpler than Einstein's equations and accurate enough for most applications. But Einstein revealed what gravity actually is. Not a mysterious force pulling objects together across empty space. The curvature of space and time themselves. Mass tells space how to curve. Curved space tells objects how to move. When you step on that scale, you're not measuring a downward pull. You're measuring how hard the scale must push to prevent you from following your natural path through curved spacetime. When you observe something fall, you're seeing an object finally free to follow the geometry that mass has woven into reality's fabric. When you look at the moon, you're seeing an object following the straightest possible path through the curved space around Earth. A path that appears circular because space itself is curved. Space brings objects together. That's what we call gravity. Not a force. Geometry. And that is far more beautiful than any mysterious pull could ever be.